We're given two matrices, -1 down below 7, -2 down below 4. That's labeled matrix B. And the second matrix, which we name C, capital C, is the matrix, it's also a 2 by 2. It's -3 down below 2, -4 down below -5. Now they asked us to find the following linear combination of those two, -C minus 3B. Solution, -C minus 3 times B is equal to, now first we'll do the -C. The -C is acquired by taking the matrix C and changing the sign on each of the entries. In other words, multiplying each of the entries by a -1. And that gives us a +3 down below a -2, a +4 down below a +5. That's the C, -C. And then minus 3 times, okay, 3 times B would be multiply each of the entries in the B matrix by +3. Now, I could make this a plus sign in between the two matrices and then just multiply each of the entries by a -3, but might as well just leave it as a negative for now and just multiply by 3. So 3 times -1 is -3. 3 times 7 is 21. 3 times -2 is a -6. 3 times 4 is 12. All right, let's simplify. In the upper left entry, I have +3 minus a -3. 3 minus a -3. In the lower left entry, I have a -2 minus a 21. Okay. In the upper right, I have 4 minus a -6. In the lower right, I have a 5 minus 12. Okay, let's clean it up. That gives us in the upper left, 3 plus 3 is 6. In the lower left, -2 minus 21 is -23. In the upper right, we have 4 double negative makes plus. 4 plus 6 is 10. And in the lower right, we have 5 minus 12, which is -7. And we're finished. And once again, you'll notice that we were working only with 2 by 2 matrices because we couldn't subtract these matrices. We could not add or subtract anything with the C and the B unless they had the same order. So these were both the same order. They happen to be 2 by 2s. We could have used larger, smaller, but we used 2 by 2s. And of course, since subtracting means that you subtract corresponding entries, your final answer will also be a 2 by 2 matrix.